Alright, this video is going to focus on calculations. This is chapters 2.5 through 2.12 in the Talking Through Code textbook. So let's get started. We're going to open PyCharm just like we did in the previous video. And we're going to open Talking Through Code chapter 2, that project. So now we're in the Talking Through Code chapter 2 project. And I want to make a new Python file, right? We've been making new Python files every video. So new Python file. And we're going to call it calculations. So I'm going to hide the left pane now. And let's look at how these calculations fit together. So the only type of statement we've seen so far has been an assignment statement. And later we'll look at if statements, while statements, and for statements. But we've done an assignment statement so far. But now we're going to be looking at expressions. And expressions are things, it's a combination of math, literals, function calls, anything that can come together to have a final answer. So an expression might be 1 plus 2. It might be calling the input function and adding an exclamation point to the end. It can be several things. So before we talk about calculations, we have to talk about operators and operands. So operators, this is things like plus, minus, divide, multiply. This is for powers, right? This is like 2 to the third. There are parentheses. Those are part of the things. And then there's integer division. And there's modulus, which we'll talk about as we go. So these are the operators that we have to deal with. And these operators act differently depending on what the operands are. So the operands are the values that the operator is being applied to. So if I have something like 1 plus 2, plus is the operator, and 1 and 2 are the operands. So keep that in mind as we go through. Operator is the symbol that's indicating the operation, whereas the operands are the values that the operator is being applied to. So we're pretty used to the way that these operations work, right? Basics. But what about integer division? How does that work? Well, division gives back the quotient of division. So the quotient is exactly how many times does one go into the other. So if I print 10 integer divided by 3, I get 3, right? 3 times 3 is 9. One more 3 would not fit in evenly. So that's how we ended up with 3 for the answer to our integer division. If it does divide in evenly, then the quotient is just the same as what we would expect it to be, right? 10 divided by 2 is 5, and so that's the exact quotient if there's no remainder. If it doesn't go in at all, so 5 divided by 8, we get a 0. Which makes sense, right? 8 cannot go into 5, so that is a 0 for the quotient. So let me write this down in the code. So this is a 3. This is a 5. And this is a 0. All that makes sense, right? Integer division is just getting the quotient. Integer division is also called floor division sometimes. I think the textbook refers to it as floor division in some parts. Now there's also modulus, which gives back the remainder of division. So remainder. So this is the remainder. So let's redo those three the math we did on lines 11, 12, and 13, but with modulus instead. So we're going to print 10 mod 3. We're going to print 10 mod 2. And print 5 mod 8. So let me do an extra print to make sure we can see the difference between the integer and the modulus. So modulus is giving us the remainder. So the 3 times 3 from integer division is 9. And then 10 minus 9 is 1. So that makes the remainder a 1. So this is 1. This is 0 for dividing in evenly. So what we learned from line 18 is that if the right operand goes evenly into the left operand, the remainder is 0. And that's true all the time. So it's an easy way to check for things like, is this number even or odd? Right? 10 is even. We can tell because when you mod it by 2, it's 0. On line 19, we see that when the left operand is smaller than the right operand, the remainder is just the left operand, right? 5 is less than 8, so the remainder has to be 5 because 8 cannot fit into 5. So modulus is a good way to strip off the rightmost digit in a lot of instances. So we'll see modulus work more in later pieces. So I'm going to move this back down here. All right, so we've got integer division and modulus. So we can do math in code. What if we want to be able to do math with stuff that the user has inputted? So we saw in the last video when we tried to get the age that inputs always return strings. So we want to be able to convert from a string to numbers. And the way that we do that is with the int and float functions. So in the same way that the input function returns something, the int and float functions also return things. So we're going to have to save off those values or print them directly. So let's relook at getting a person's age. So I'm going to say the age string is equal to input, enter your age. So we're going to have them enter their age. And let's put another print statement to separate these examples. So we're going to get their age. We know this is a string, and I want to be able to do math with their age. So I want to convert age into an integer. So age int. So the int function takes in a string and gives back an integer of that same string. So let's run this. Enter your age, 35. We didn't do anything, but it did work, right? Assuming this is Bruce Wayne's age from the previous video. So we entered Bruce Wayne's age of 35, and we converted it to an integer, and it works. But because there's no like safeguards here, if I do 35, I get an error. So what we're seeing here is we cannot use the int function on anything that is not actually an integer. If we try to put a string that wouldn't convert nicely to an integer, like the words 35, it throws this invalid literal for int error. So we have to be careful. So it doesn't work if I do a string 35. And let's see if it works if I enter a float. So it also doesn't work if I enter a float. So it has to actually be a string completely. Okay, great. This also works for the float. So I could have done a float. No, let's go again. Pi string, but enter pi to a bunch of digits. say float. So here we can, take a number and convert it into a float in the same way that we took a string and converted it into an integer. Okay, great. So this makes it where we can do math with user input. If I wanted to make my code a little bit more streamlined, instead of doing it in two like I did here, I can nest the calls and instead do that age int is equal to int put enter your age. So all in one line as opposed to doing it in two separate lines. I like it better the way on line 25 just because it's fewer lines of code and I still think it's just as readable. So keep that in mind as you're going through. Anytime we have these functions, we can take what is returned by one function and use it as an argument for the next function. Sort of like a nesting of these things. All right, so now that we've converted information into a form that we can use for operations and expressions for math and calculations, what is the order of operations? Order of operations. And luckily for us, for ease, PIMDOS still applies. So PIMDOS. So the P is still parentheses. The E is still exponents. This is the double. M is still for multiplication, but also modulus. So mstick. D is still for division, but also int or for division. A is still for addition, and S is still for subtraction. So it's nice, right? PIMDOS still holds, and even the M for modulus and the D for integer division stay where you expect them to stay. So I tend to overuse parentheses in my expressions just because it makes me feel better. So you'll see that in some of the code that we write throughout this, that I have too many parentheses and they're just there to make me feel better. Okay, so we've got this. Now, not every operator can be used on every type of thing. For instance, let's say that I have this string. So greeting equals hello world. I can do concatenation on it, which is addition, right? I can say greeting equals greeting plus then the emoji. So now greeting has had that emoji appended to the end of it. So this is concatenation. So addition obviously works. What about multiplication? So greeting equals greeting times 2. That seems to be working. So let's print greeting along the way. Greeting. So I'm going to do something real quick, which is I'm going to comment out all the rest of the code that we have. So I did that by doing command / to comment or uncomment in a block, because I don't want showing up a bunch of code in my output. So this was one copy of greeting, and then this is a second copy of greeting. So I got 2 copies of greeting. Concatenation. Yeah, there we go. So I had 2 copies of greeting. That multiplication, totally fine. But greeting times if I try to multiply it by a string, it doesn't have a syntax error because of the dynamic typing within Python. So the interpreter, the thing that's looking at this to determine if it would interpret, it can't tell that we're multiplying a string by a string here. But if I run it, I do get can't multiply sequence by non-int type str. So this means I can only multiply strings by integers. I can't multiply strings by strings. I can't multiply strings by floating point numbers, right? It has to be a string and an integer in order for the multiplication to work. All right, so if addition works, does subtraction work? So greeting equals greeting minus exclamation point. Again, this doesn't have any syntax implications because of the dynamic nature of the variables that we have, right? It can't tell that greeting is a string and the literal is a string. So we're going to run it. It stops the multiplication because that was the first bad line. Let's rerun it. Yeah, so we can't do subtraction for strings either. So addition works, multiplication works, subtraction doesn't work, division also doesn't work. So the only things that do work are addition and multiplication, and even then the multiplication has to be a string times a number. So watch out for this. Okay, so we've looked at the fact that we can do math, we've looked at some of the operations we can do. Let's slowly build up what it needs to look like for math to make sense. So I've got 3 plus 4. This is a valid expression, right? We know that 3 plus 4 is 7. But I'm not doing anything with that information, right? It doesn't mean anything. It's just some code in the middle. So I'm going to update this to be answer equals 3 plus 4. Still no output because I didn't print answer. Now that I get 7. So I can create variables that are equal to expressions, full expressions that do multiple things. If I wanted to be able to get this information from the user, so I'm going to put original number is equal to int, input, enter an integer. So I'm going to take an integer from the user and convert it to an int. And now our code is going to add 4 to whatever the user entered every time. Great, right? This is a great combination of what we talked about in the last video and this video, being able to use user input to affect the output for our code. Okay, this 4 is a magic number, which we talked about in a previous video as well. So I'm going to go back all the way to the top, right before the code starts. I'm going to say that the shift amount is 4. So shift amount is a constant. And I'm going to scroll back down here. So that way now I can see that answer is equal to the original number plus the shift amount, which reads very much like a natural language sentence, right? It could be just a regular English sentence. Answer is the original number plus the shift amount, which is nice. We want our code to be as readable and understandable as possible. All right, so this was a very simple expression. There can be compound expressions, which is essentially when there are many operators involved in some calculation, right? Your expression is more complicated than just something like what's on line 54. So the example from the textbook for composition is the compound interest formula, which we're not going to look at as much here. It's just, I don't think, very useful in a video. But just remember that a composition is when there are multiple operators and they come together to create a more complex expression. That's pretty much what you need to know about composition. All right, So this is all about some calculations. We didn't get very complicated, but we learned the operators that can be used, integer division and modulus, and then we talked about what operators are allowed to be used on strings. Before we go, we need to look at one final example is what happens if we forget to turn original number into an integer. So we're going to run it. Can only concatenate strings, not ints to strings. So you've got a problem. Original number is a string and shift amount is an integer. What if we tried to fix this but we fixed it wrong? So we've got this current runtime error and I'm going to try to fix it. I'm going to change shift amount to a string. And now I've got 454 when I probably want it to be 49. This is a semantic error, right? My code, there's no syntax error, so it will run. There's no runtime error, so it looks to be right, but it's semantically wrong. We got an answer that is not what we wanted. So instead of converting the shift amount to a string, we're going to convert the shift amount to the original number to an integer. And so this is a practice in knowing what errors mean, but also knowing what is our expected output, right? Our expected output was 49 for 45, and when we didn't get that, we got a semantic error, and we had to figure out what was going wrong there. So always be careful that you're working towards the correct answer for your code, and not just code that runs. All right, so the next video is going to be about escape sequences and formatted strings, with its chapters 2.13 through 2.14 in the textbook.